Now in this example we are turning logic gate circuit into truth table and logical expression, right? Now this is the circuit given, right? So how many inputs? 3, no? Then you know there are 8 possible combination, so 0 to 7 values you should be able to write it in binary. Then you can take E column, F column separately. For A and B output E and not C, F. After that you can compare these two and write the D, right? Otherwise straight away you can see here, so this to become 1, this branch need to be 1, this branch, both need to be 1, right? Both need to be 1, right? So this get 1 if A or B 1, but this get 1 always C is equal 0. So it's very clear, we can see where C get 0, where C get 0, other condition A or B need to get 1, right? Here C get 0 but A B also 0, you can't. Here C get 0 but A or B 1, right? B is 1, therefore you see output is 1, it's possible, right? Here you can't, again here the C 0, A or B 1, right? So now here the A is 1, therefore you get the output 1. Similarly see here C 0, A or B need to be 1, both 1 mean no problem, no? At least either one is you are getting 1, so both 1 mean definitely you are getting 1, no? So here, and you can place all others 0. So looking at the logic gate, you can derive truth table and you can write the Boolean expression. Very simple, no? Here the final result is with AND gate, so therefore here the AND only in the middle. Then one branch is not C, the other branch is A or B. Therefore don't get confused, right? You need to see where is the output coming, then only you need to see the branches. You write both sides. When you are writing the branches, you can read this now. This is C, here the feeding is not C. What is feeding here? A or B. So here whatever the way, this way also it is clear. This or this you can write. Now see here, how many inputs? 3. Then 2 to the power 3, 8 combinations, 0 to 7. Either this need to get 1 or this need to get 1. So you can separately fill this column and you can O these two and see. Otherwise either this or this need to be 1, no? So this to get 1, A and B need to be 1. So you see all possible combination A1 B1 here, then you get 1 here. Other possible combination A1 C1, so you see where you get A and C1, then you get 1, all others 0. What is the Boolean expression? Here the gate is O, no? This branch is A and B or A and C. Now you won't get 4 inputs, right? But even these things should be very clear. Why? 4 combinations means 2 to the power 4, no? 4 signals mean A, B, C, D, 4 different signals. Then 2 to the power 4 mean you should be able to write from 0 to 15 in binary. Then same way we can see all the combination and place 1 and others all 0. Now see, it looks like a complicated circuit but only 2 inputs. Therefore 2 to the power 4, because here it is giving for the both branches, no? Then 2 to the power 2, right? Only 2 signals, no? 2 to the power 2 mean 4 combinations, that is 0 to 3. Now you are very familiar how to get this output, and even if these things are given, that's also you should be able to write. But in this case, Z to become 1, either this or this need to become 1, no? Right? First we'll take this branch. First we'll take this branch. This to become 1, B needs to become 1, C needs to become 0. Then you have to see A0 B1. You see A0 B1. Only this combination is there. Then you place 1 here. This branch to become 1, A1 B0. Then you see where A1 B0 here. Then others you can fill with 0. Right? Now you should be able to write the Boolean expression as well, no? Because here is O, no? So this branch, how you can write? A no, not A, B. B directly feeding, no? B and not C in the bracket, O, A and not B. Here 2 combinations, 2 to the power 2, 4. Now straightforward, right? These things should be very clear now. Here D is the output, so we can even write from here. What is the output you are getting here? AOB. AOB. Then what is happening here? That result is AND with C. AOB and C. AOB and C. And C. Now this is the output here. Then the entire output is not. Finally you are getting whatever the result you are getting, everything is not, no. So therefore you write a bracket for everything and write it here not. This way also possible, right? Without this AND word, if you are writing, how you can say? A plus B. AOB. Here you can place a dot. C dot inside the bracket A plus B. Right? Then entire thing you need to put a bar. The entire result is bar. Right. Now see this. Now this is the condition. Fire alarm goes off. No, we say goes on, right? Fire alarm goes on if either the temperature inside the building rises above 60, someone manually activate a fire alarm. Right? So 2 conditions, no? Right? 60 or someone manually activate. So then definitely for these 2 conditions there should be a OR gate. Right? There should be a OR gate. Then firefighter should be able to manually shut the fire alarm off regardless of how the alarm was triggered. Right? We don't care whether it is above 60 or somebody else trigger the alarm, but firefighter should be able to off it anytime. Now this is okay. Either this or this, we can set the signal directly to the alarm. Then if firefighter is not doing anything, according to this circuit, it get feed and alarm should on. Now this stage firefighter is not doing anything, mean there should be 1 when firefighter is not doing anything. So the firefighter signal should go with NOT gate. Right, here you see, this is how we think. Now this is one condition, no? Okay, either this or this, the signal should fed. Alarm should go on, but there is another condition, no? The firefighter also coming, no, here. So firefighter is not doing anything. According to this, we should on the alarm, no? So to on the alarm, this need to be 1, no? So therefore the firefighter signal should go from NOT gate. He is not doing anything means 0, no? So not doing anything, this need to be always 1. Then only either this or this, you get 1 here, then alarm should go on. While this is on, firefighter should be able to off. So now only firefighter activating the signal. So that means if firefighter input a signal, activating mean 1, no? Then it should go from NOT gate, then this becomes 0, this is the AND gate. So even though this is 1, if this is 0, the signal is 0, this gets off. Right, now it should be very clear, right? According to the problem, you should be able to see, always you separate the branch. One branch is solving the problem, then if firefighter mean, you need to assume if firefighter is not doing anything also, this should work. Same time firefighter should involve in the circuit. So you can place an AND gate and say if he is just waiting, this need to be 1 or this to work. So he should be forcefully off also. Then whenever he inputs a signal, this should go off. So then the AND gate is coming to your mind, no? Both 1 only it work. If 1 you want to make it 0, that should be the AND gate. If for either functions to work, then it should be the OR gate. Now the Boolean expression is very clear, no? This is one branch, this is the other branch. 1, 2, 3, that means 8 possible combinations. Separately you can fill this and you can compare these two for this. Otherwise, this to become 1, either A or B need to become 1, correct. This to become 1, C need to be 0. So therefore always C need to be 0 here. Always C need to be 0, this to work. So then you have to see the condition where C 0, either A or B need to 1. So here C 0, B 1 here, then it is 1. Then we will see the other C 0 is this one. C 0, A is 1 possible, here 1. Then we see this C 0, either A or B need to be 1, no? So therefore both 1 mean no issue at all. If any of this 1 mean 1, then here both 1, that also 1. Then all others we can fill with 0. Right. Now regarding truth table, Boolean expression, logic gate circuit, there should be any doubt. Without any hassle, you should be able to answer all questions related to logic gate. Thank you.